Okay? So why science? We got these three kind of categories here: pessimist, optimist, and a scientist. Okay, what is an optimist?
Glass half full.
Glass half full, okay. Pessimist?
Glass half empty.
Half empty, okay. What do you think an optimist sees?
A yummy pie.
A yummy pie. Okay. I'm just going to get to kind of an aspect behind this. You'll notice that I can annotate. One of the other things that I'm doing is I'm actually recording during the lecture as well. Okay. All of these lectures get recorded and posted to YouTube. Okay, so an optimist sees yummy. What else might an optimist see?
Full.
What?
Full.
It's a full pie, whole pie. There we go.
No slices, so it's mine.
Like, yeah. What does a pessimist see?
Calories.
Okay.
Oh.
Yeah.
There's no hyphen.
Yeah.
I'm attempting to be subtle. What else might a pessimist see? There's fruit. I mean, that kind of goes back to that, but you know. Okay, messy. Okay, probably tastes horrible because it wasn't made with the proper ingredients. Okay, this is a pie clearly in Arizona. Strawberries grow better on the coast of California in the middle of summer. We're not quite there. They're out of season. That's going to be a crap pie. Okay. What does a scientist see? You're like, dude, you had a lot of words for that. You might see where I'm aligning on that spectrum. What does the scientist see?
Depends on what it is.
Okay. Good look at baking times.
Ingredients used. Ingredients mixed.
Ingredients. How did you say oyster?
Bacteria, you said, how is it poison?
Is it poison? Wow, okay.
Whether or not the strawberries are organic.
I always hate poison. Did I get that right?
Yeah.
Yeah? Cool.
It's poison. Yeah.
Is it poisoned,
Bacteria.
organic, bacteria?
Origin of the ingredients.
Okay. So are we seeing a difference with the scientist?
Yeah.
Kind of to get drilling down into those nitpicky details behind what makes that pie. Right? Those are important to the scientist. But the next part is what really makes a scientist. Why? Why does a scientist care about the baking times? Or that there's glucose?
It's
Right?
a variable. You want an answer?
Yeah.
It's a variable that affects the final product.
It's a variable that affects the final product. Because what is the scientist trying to do?
Prove a hypothesis.
Make the pie the best. The scientist sees that and says, I don't necessarily care about the optimist or the pessimist, but I can make that pie better. Right? And the way I'm going to make it better is I'm going to identify all the things that went into it, and I'm going to say, well, your strawberries came from Arizona. The wrong time of season. We need to source those strawberries at the right time of season because that's going to change the flavor profile. Right? And then what does the scientist do?
Test it.
Gets the right strawberries, builds the experiment, and makes it. And then says, here's my pie. Now what? Is it better? Maybe. How would you know? You've got to test it. You've got to try it and actually see, did you make it better? If you did make it better, now what could you do?
You improve it even more.
You could just eat it for yourself. That tends to not be scientists so much. Scientists then take that result and take it back to the person that made, hey, look at this pie I made. And they're like, and they can bring back the pie and say, here, you should try this. It's better than yours. Okay? And they want to show that off. Okay? For a variety of different reasons. Some of it is just progress. Like, hey, let's all get together and make some better pies. Like, this doesn't make sense to eat crap pies. We only live so long. Let's, make the best of it. Okay? It could also be that egomaniacal, like, I'm going to prove that I am the best pie maker there is.
It may also help to think of it not as pies, but as milkshakes. My milkshake is better.
I don't think I'm going to walk up to get that one recorded. Okay? So our scientists are really pushing to make things better. And to do that, we have to look at each of those individual pieces. Does that mean we're always successful? No. We had some people that said they like to cook, right? Strawberry, we don't really have to cook the strawberries. If they're legit strawberries, we don't need to cook the strawberries on our pie. But what's this weird stuff on the outside? That's a crust. The crust, we should arguably cook, right? Anybody not cooked the crust of a pie? Yeah, how'd that turn out?
Turn into a burrito.
Nice. Okay, so in making that crust, we need flour. Okay, they used white flour. Well, that's not very healthy. I'm going to use whole grain flour because that is better for you. Okay, you get a crap pie out of that. Okay, so we can make those adjustments, but they will fail. Okay, we now have to record that so other people know not to use whole grain flour or whole wheat flour, I think is the one I'm going for, instead of the bleached white stuff.
Brown flour.
Okay? We could switch up the sugar. They probably used white cane sugar. Man, that's just tasteless. What should we use instead? Stevia. Wow, man. Opposite direction I was going. I was going to go like turbinado sugar. Okay, a little bit less processing, maybe a brown sugar that has a little bit more flavor and character behind it that can build that flavor profile. Okay, so we would make those adjustments and take note of it. That's what the scientist is trying to do. Okay, some of their reason why is, hey, I just want to make it better so that people stop eating crap pie because that's just not cool. Other people do it because now I can sell the best pie in the world. Okay, or I can get credit for it. But when we're looking at science, that's what we're doing. We are building pies. We're just building pies with things we can't see when we look at chemistry for the most part. Okay? So what might be the process that we would go about to do this? We heard some of those terms get thrown out. I heard a hypothesis. I heard an experiment. We get the scientific method. Okay? So if we're going to learn something new, as our ultimate goal, we have to have a process behind how we go through and do it. So we'll make an observation. That was an ugly pie. Okay? And now I'm going to say that I can adjust it. And by adjusting it, what am I going to do? Okay? How? I want to, instead of using white flour, I'm going to use whole wheat. Why would I make that change? To make it healthier. Okay? I might make it healthier, but what's one of my other goals? Flavor. Does it taste good? I have to balance those two and decide which one's my priority. So I'm going to make a hypothesis. Okay? And I'm going to decide that whole wheat flour is going to somehow make the pie better for one of these categories. Then what am I going to do? I'm going to test it. Okay? By making an experiment. Right? This is looking pretty linear. Like, this is cool. Everybody's like, science is great. You just do one step, and then the next step, and then the next step, and we become famous scientists. This is awesome. I love this. What's the next step? Okay? Conclusion. If you look at your textbook, you'll come up with two conclusions that come out of it. Law and, you can see how much I value it. Law and theories. Okay? So it's just the next step forward. And that's wrong. It actually fails. Okay? Your experiment was an utter failure. Right? And this is where scientists really kind of make the grade and make that big step out. Is that when it fails, what do? They go back to the hypothesis. And they create another experiment. And then what happens?
The outcome changes.
The outcome changes. And then we move into a theory, right? Or a law. No, it fails again. And we create a new hypothesis. And then what happens? We get a new experiment. And then what happens? Fails again. Right? Like if I tried to walk through a wall, right? I'd walk into it. And I would hit the wall. Well, that didn't work, so I back up. And I try again. And if you saw someone doing that enough times, you would probably say, they're insane. What are scientists? They're insane. Okay? And they're insane, but they are changing things. It's not just constantly doing the exact same thing again and again and again, but it is noticing that they're failing each time. So instead of walking forward into the wall, they now backed up and said, I'm going to turn a half a degree to the right and try again. Ow! I'm going to try again. And they keep going through all of that pain and suffering until eventually they make it through the door. Okay? And that door ends up coming in as contributing to our scientific theory or natural laws. Okay? The problem that I have with how the textbook has discussed this and how I think most science is presented is that it's presented like this. So when you as a student come in and look at the scientific method, it's awesome. We make an observation. I make a question about it. I design an experiment. Ta-da! I'm now a scientist. What they don't tell you is that all of those scientists failed miserably hundreds of times and were insane enough to keep running into walls and to keep making those micro adjustments to their actions in their experiments to progress forward that they could eventually achieve that experiment. Okay? Or not that experiment, that theory. Get to that conclusion that they could be like, look what I did. And then scientists do another sneaky, backstabby thing. The scientist that now made it all the way through and says, look at what I did. What do they show you they did? They show you that they walked through the wall. They made it through the door. Like, oh yeah, it was awesome. It was fantastic. It was so easy. Look at how great I am. And you're like, cool, I'm going to try that too. And what do? You walk right into the wall. Okay? Because as scientists, we don't show you the failure. That was 800 years of people dying literally to progress this forwards. We don't want you dying. Right? You might feel like dying in the class. Okay? When you run into that wall, when you can't solve that question. But ultimately what we're trying to do is to get through that stage. Okay? And to get you to realize that you can fight through that pain, you can deal with that failure. Okay? I'm going to make an adjustment to that failure in a second to move forward and to advance towards your future goals. Okay? Because we need more people thinking like scientists and attempting and fighting through that failure and working to progress instead of more people saying, no, this is the way it is and I'm just going to be done with it. Okay? We have to think and broaden how we interact with the world and try to move forward as a populace. Kind of make sense? Okay? Might be small parallels to like lots of other things in your life. Okay? Politics. Maybe you want to become a doctor. Okay? You're making these same steps through. You will encounter that failure. I want you to be okay with that failure to progress forwards, which is what we're going to change with this. Everybody freaks out that I talk about failure. I want you to fail this class. Sort of. I want you to fail in this class. Like, that's not any better, you jerk. It absolutely is better. I want you to fail in this class so much that you now learn how to succeed. And by the end of the class, You're not getting an F in the class, you're getting an A. You've picked up that content, you know how to use it, manipulate it, and move forwards. But what I want you to do in the classroom and with practice is to fail, because that failure is how you will grow and move forward. So how could we manipulate this? Using our linguistic knowledge of language to be like, let's make that failure not seem so bad. Like, I don't know, like failure kind of sucks. Well, let's try. I'm going to try an option. Let's see, does this make it better? And as I'm looking at this, I did spell that right, didn't I? Okay. Did I make it better? You look at that and you're like, yep, that's exactly what I want to see in day one of my chemistry class.
Is that more along
Failure.
the lines of what you want to do, or less along the lines of what you want to do?
What do you guys think? Is there another way we could represent that? Here, I can give you another one.
What was the question?
How could we adjust our viewpoint on this word to make it less painful?
How can we adjust how can we rephrase the word, or how can we improve our relationship with the word failure?
We can look at it that way, but we're now trying to switch a little bit into the English language. What tools do we have in the English language that would allow us to say, actually, that's not this big, giant, bold, glaring thing at me?
When it's
What
bolded
literary
like
device?
this, when it's all caps, does it make you feel like something that you could survive?
You got a text message from your mom saying, come home now, that's all caps. What's going on? What was that? Oh, monkeys, I better get home now. Something's about to hit the fan. Okay? What did I forget to do? Take it off caps lock. Changing the font takes it from failure to, hey, it's just failure. That was kind of loud. Sorry. Okay? That's a big difference. So when we look at failure, it's not capital F failure. It's lowercase failure. It's small failures. Okay? That's the stages we want to move through. Okay? Kind of makes sense?
The type of
Yes.
failure we want you to have in the learning community is a failure you can grow from, a failure that you can develop further from, not a big F failure where there's no hope of success ever, but a little F failure where it's intentional and strategic so that there's hope to grow and learn and build on what you've already
They
get.
say failure is the greatest teacher, right?
Failure is a phenomenal teacher. I would know. What was I hired for? Did anybody remember? Why was I hired to teach here?
Organic chemistry?
Organic chemistry. Okay, so I took organic chemistry as an undergrad. I'm teaching it. Theoretically, I learned it at some point, right? First time I took it, I had to withdraw because I was failing the class miserably. Okay? And yet now what am I doing?
Teaching.
I'm teaching it. Arguably somewhat decently. Okay? They hired me, right? So where does chemistry fit in the big picture of everything?
It's the science that ties all the other ones together.
Yeah, chemistry is the one that allows everything else to exist. Without chemistry, math is nothing, physics is nothing, biology nothing. All that's just crap. It's all about chemistry. You're laughing already. Kinda. Of course, that's coming from a chemist, right? Okay. Mathematics and physics are kind of the epitome of all science, in my opinion. Mathematics is the super abstract. It's how can I make a way to describe the environment that I see, okay? And I can use numbers to manipulate that, okay? Depending on the field of mathematics, there are mathematicians, my parents were some of them, that took classes from math professors that their sole job existence was to come up with some mathematical expression that could describe absolutely nothing. They wanted a mathematical system that couldn't be tied to anything. Why? I don't know. They liked numbers and wanted to play with them. Okay? till some jerk comes along, sees those equations, and goes, you know what? That kind of looks roughly like, well, I don't know, a circle. This cannonball that's flying out of the air. And you get physicists. Okay? Physicists start to apply some of those principles to smaller and smaller things. That brings us into quantum, which, depending on who you talk to, is it quantum physics or quantum chemistry? It's quantum chemistry, clearly. Okay? And you now get chemistry taking sense of all of that mathematics and numbers that was nonsense, and the physicists that are just doing weird stuff, exploding things, and tries to actually position that to be useful. So depending on which end of this bridge we're on, in the hardcore mathematics or physics, or in the end application, maybe biology, and you can see my perspectives, other things that are out there, okay? They're now not concerned about as much the mathematics and physics. They're concerned more about the application of those end pieces. Chemists have to bridge that gap. Okay? The crazy people that only understand numbers and the equally crazy people that are like, what's a number? Okay? That's chemists. Okay? Chemistry as a field itself breaks into several subdivisions. You get general, which is kind of what you're in. It's supposed to cover everything. Okay? Which is a horrible thing to do to any student. Like, welcome to chemistry. We're going to talk about everything that we've done for 800 years. Okay? That's not a good philosophy, but that is the philosophy that we're working within. Okay? If we break down that field, we see subdivisions, and we can get subdivisions of these. But we get organic chemistry. This is looking at molecules made up of carbon and hydrogen. Okay? Living objects are organic. How can we make those objects? That's an organic chemist. A biochemist now doesn't care necessarily about making those objects, but cares about studying the objects that was made. Okay? How do those affect living things that we work with? Like drugs. Okay? Pharmacists are fancy biochemists. Argue the other way around, but that's okay. Inorganic chemistry is now taking everything that wasn't carbon and hydrogen and saying, well, how do all those pieces interact with each other? So organic chemistry, this one that everybody freaks out and goes, oh my God, you probably do it. It's carbon and hydrogen. Inorganic is the rest of the freaking periodic table. And nobody goes like, oh my God, my inorganic chemistry class was the worst thing ever. Okay? It's so large with inorganic chemistry that it becomes difficult to nail down. Okay? You heard of solar cells? Mm-hmm. LEDs? Mm-hmm. Okay? All of those are inorganic chemists. Okay? Also sometimes referred to as engineers. Okay? Those are ultimately the job position, if you will, of an inorganic chemist. Physical chemists are just the loony bins. Those are the guys dealing with the mathematics and the physicists dealing with the quantum stuff where an electron can be here and make it to the door without passing through the space. Okay? Yeah, it's just weird stuff. We'll talk about little bits and pieces of each of those. Kind of make sense? And Greg's been furiously panting in the back of the room. I meant to say pacing. Just swap out just a couple letters and it just changes everything. Okay? Because he doesn't seem to agree with this philosophy that chemistry is the bridge. Chemistry is what allows these things to all exist. So let's hear that argument.